Hi everyone, welcome back to my channel. Have you ever wondered how your emails know which messages are spam and which one are, let's say, important, and this goes to the inbox? And have you also know how the Netflix recommend, let's say, the perfect show for you? So that's all about how your model can separate the right choices from the wrong ones. So, and that's where the ROC and AUC come in. So many people think, let's say, accuracy is enough to measure the model performance, but this is not always true, especially when you're dealing with, let's say, fraud detection, medical diagnosis, or spam filtering, and when you have, let's say, imbalancing data set. So in this video, I will try to break it down in a super simple way, as you can see, with real example and visualized. And I'm quite sure that you will never be confused about ROC and AUC again. So because this took much time, so if you like this, please subscribe into my channel and like this video. And of course, if you have any question, please write it down in the comment below. So the ROC, let's start now. The ROC curve and AUC are used for binary classification. So the ROC is called receiver operating characteristic. It's a curve is a graphical representation of the trade-off between true positive rate and false positive rate. And this is AUC, it's under area under the curve. So this is the area under the curve. We can calculate it and see how our model is good enough or not. And as you can see here, the AUC, if the AUC that we will calculate it in the section below. If it's 1, our model is perfect. If it's zero point 0.5, it's randomly guessing, let's see. It is less than zero point 0.5, it's not anymore. So it depends on AUC. If your model, let's say, greater than zero point 0.5, I will say it should be, I mean, not okay, but you have to, let's say, improve the model, and 1S should be perfect. So let's assume that we have a positive, email spam email classification that I have also used for the previous video for the recall precision and accuracy and F1 score. So I'm assuming this positive class is a spam email and negative class are not spam, or let's say ham emails. And please keep in mind that F1 and recall and precision also focus only on one on the positive class and doesn't show how well your model does on the negative class. So if we are focusing now on the spam, and we see the spam is the positive class, so now the ROC, it will only show us the performance of our algorithm only on this class, and the ham, let's say, class, it won't be showed here. And you can also assign, let's say, change the positive class to ham and see what is the performance. So this it depends on you. And also this already covered in the last video. And let's say this is, let's see our emails here, email 1 and email 2 and email 3, and our class, sorry, our class for the first email is spam, and for the second email it's not spam or ham, and email 3 is spam, and etc. Now this is our predicted score. So how to get this predicted score? If we remember in logistic regression, our model is predicting a probability. This is, let's say, greater than zero point 0.5, it should be 1, and less than zero point 0.5, it should be 0, or let's see the other class. So now we have this, our, let's see, our model is predicting scores before the classification is predicting the scores. I will show you also in the code. And this, please keep in mind, this is not randomly generated. So this is predicted by the model. And As you also remember in the logistic regression, we said if the model is, if the prediction is greater than zero point 0.5, we see this is, let's see, spam. If it's less than zero point 0.5, we see it's ham. But now we need to see what is the best threshold that can separate our spam and ham perfectly. So in this case, not only zero point 0.5, it could be, let's say, 0.7, or it could be zero point 0.9, or it could be I don't know, zero point 0.4, let's see. And this we will cover in this lecture, how to choose the perfect, let's see, threshold. So for this calculation, we also need to calculate the true positive, false negative, and true positive. And also we need to calculate the true positive rate and false negative rate. And true positive rate is called also, by the way, recall or sensitivity. And this is the false positive rate. And as you can see, this is only a copy from this. So it's just to show you the dataset. So now let's assume this is our prediction. This is on the validation or the test set. Test set. So now assume that our model for the for the first class is predicting zero point 0.9, for the second 0.85, and etc. Now I will try to use these thresholds, all of these thresholds, and see how my model is separating these two classes. So I will start with zero point 0.9. Let's see here, for instance, zero point 0.9. And they have email 1, 2, 3, 4, 5 till 6, right? And why it's 1, 0, 1, 0, 1, 0. This is, let's see, spam, ham, spam, ham, spam, ham. And for the prediction, if I see from zero point 0.9 equal or greater 0.9, it should be spam. And if we see here, we have only this. So this email will classify it as spam. As you can see, spam, and the others is these probabilities less than zero point 0.9. So it will be assigned to 0. Now let's calculate the true positive, false negative, and true negative. So as you can see here, this class was spam, or let's say positive. Now and calculated as positive, I mean predicted as positive, so it will be true positive. It's only one. And for the false negative, false positive, we have no false positive here. What is the false positive? If sometime if the email is ham or not spam and classified as spam. As you can see here, this is 0, but it's predicted as 0, so it's not 1. So it's not, there's no false positive here. For the false negative, we have this spam here, but it's classified as 0. And this one here is classified as 0. So we have two false positive. And the false negative, this one is 0 and predicted as 0. 0 predicted as 0 and 0 predicted as 0. So we have 3. So I just try to simplify this, and we have to do all of this for the same for the all let's say thresholds. So we started with this one, and we have to do the same steps with the second threshold. And I have just prepared this table here. As you can see, yeah, I just forgot to mention this. The true positive rate and true and false positive rate, we can apply this here. So it should be true positive plus, for instance, we have 1 divided by 1 plus 1 plus 2. So it's 1 divided by 3. And it will be like this. True positive, it's recall, as I said, and this is false positive rate. And we have to, as I said, we have to do it for the all probabilities score for the whole data, let's say data we have predicted on. So it might be validation or test, not on the training data set. And now we have to draw this ROC curve. So as you can see, this is, for instance, false positive rate is starting with 0. I mean, not starting, it's 0, but the recall is 0.33. So we have 0, and we'll have, I made point here, and point, let's see, 33 here, and it will be also in point 3. Now, and etc. And I need, let's see, to calculate this um, area. It's called an area under the curve. How to calculate this area under the curve? It's using the function called I can't pronounce it, but trapezoidal. Yeah, sorry for this rule. And it's like the false positive rate, the next false positive rate minus the previous one, and multiply by the true positive rate, the next true positive rate minus the previous one. So it's like starting from here. Uh, this minus this, multiply this minus this, divide by 2. Next, this minus this, multiply by this minus this, divide by 2. And this is just calculate the summation. And in our case, in our example, the the prediction, let's say the area under the curve, it's 67, which is not a perfect, but it's just because of this example here. So as I said here, for the function, you can use num by I to calculate the traps function. Let's see the area under the curve. But of course, there is also in a Python. I will show you in a moment. And let's see, an important question is when and when not to use the under the curve. So if you have unbalanced data set, don't use ROC because it will misleading the it will give you let's see a misleading result or performance. And if you have a balanced data set, you can use it. If you have imbalanced data set, try to use recall or precision. And yeah, you can see read it, all of this. If you have a model, some models are not predicting, let's say, a probability, so you can't use ROC. And for the fraud detection and medical tests, sometimes we have, let's say, a rare positive, which means, let's say, if you have MRI images, and for the MRI images, we are trying to classify if the MRI has a tumor or not, let's say, a disease. And for many cases, we have only rare positives, which it means rare, let's say, patients having the disease. And let me just move to the Python code. I'm not, let's say, I will not present the whole code for this, but to just show you what is how to calculate the ROC curve. And you can see here, I have the Y test. This is the class label, the actual class label of my test data. And this is the score that generated, or let's say, the result of the prediction. And here I have a positive class as a spam. And it depends on your case, as I said in the beginning of this video, you can choose whatever important label for you. And as you can see here, for instance, predict probability. The model can predict the probability, and for instance, for the support vector machine is uh, a decision function is used. But this I will cover the whole code in the next lesson. That's it for today, and if you like it, as I said, please subscribe into my channel and like the video. And if you have any question, drop it down in the comment below. Thanks for watching, and see you next time.